Hello and welcome to day 8, our last day of this unit. You finally made it. We're going to look at focus and directrix of a parabola. And this isn't necessarily intuitive on the words. You haven't seen them before. The key words here are focus and directrix. I'm going to talk about what those mean. So the focus is a fixed point inside of the parabola of the axis of symmetry. So right there's the focus. And the directrix is a line outside of the parabola that's perpendicular to the axis of symmetry. And in this case, it's usually, unless the quadratic is tilted, it will always be a y equals line. Now the great thing about this is that the focus and directrix are equal distance from here. So you can see that if you take this point, the distance from the focus to A and A to B are equal. The same thing if I took from the focus all the way up here. From here is equal all the way down. It doesn't matter which way you draw the line. If I go here, that line is the same as that line. If I go from right here, same. So the focus and directrix are equal distance from any point in the parabola. So you have this parabola, and you have this focus that is inside the curved portion of the parabola. You have the directrix that is on the outside of the parabola. The focus to the vertex and the vertex to the directrix are equal distance. And we're going to show that right down here, and I'll just go right to it right now. That this part, so here's the focus, here's the directrix. This part right here, that distance is extremely important. And since they're equal distance, we're going to call that value A. The distance from the focus to the directrix, from the vertex to the directrix, or the focus to the vertex, are equal distance. And that value right there is extremely important. So we have the focus and we have the directrix. Notice that in this case, it's the vertex curves downward, it opens downward. Here's the tiny distance right there. That's the A value. It's the same distance as that A value. Now, this one opens upward, this one opens downward. Notice that the directrix is always on the outside of it, and the focus is always on the inside of that. If you can understand that this is the directrix and this is the focus, and that those are equal distance away from the vertex, you will be perfectly fine with this. And therefore, let's see here. Okay, so we have the equation x minus h all squared equals 4 times a times y minus k. Your vertex, the vertex, just like it would be in any other form, is the inside of those parabolas. Because it's on the inside, it's always opposite the sign, so your vertex is h comma k. The focus, notice here that let's go to this one. Here's your A value. That is the distance away, from vertex to the focus or the directrix. That's really important. So that A value, which we just spent a lot of time talking about, is that distance. The focus then, let's talk about this. If I have a parabola and the focus is here and directrix is here, that focus is the vertex, the same x value of the vertex. So the same x value of the vertex, so still h, but now moved up in this case. And so therefore we have to add, well, how much was it shifted up? It was shifted up a. So it's k plus a. So we have h comma k plus a, the same x value. We then shifted up a units, and so it's the vertex y value plus that value that it was shifted up. The directrix is a line. So we know it's y equals, and the y value is shifted down a units. So instead of it being the k value, we're not going to add a because that should be shifted up. We subtract a. So it's y equals k minus a. The axis of symmetry is just the dotted line down the middle, and that's x equals h. Now this entire idea switches when we have an upside down parabola, or a parabola that's shifted downward. So if this is my focus and this is my directrix, this A value right there. So the vertex doesn't change. The vertex is still the vertex, h comma k. The focus, though, is a point. It is now shifted down. Instead of shifting up, because it was shifted up, we're going to shift it down, so we do k minus a. The directrix this time is shifted up, and so it's y equals k plus a. And the axis of symmetry doesn't change. We're still left with x equals h. So this entire idea of focus and directrix is whether it's shifted up or shifted down. And we're going to see an example of this in the next page, so I won't return there. It says determine the following characteristics and draw a sketch. So the first thing we look at, I like to look at, is what is our vertex? Our vertex is -3, because our x value always goes first, -3, comma 1. With that, I draw a sketch. -3, comma 1 is right here. I then look to say, here is our value outside of the y. Now we know it's really 4 times a. So I can rewrite -20 as 4 times -5. Which means I know this is opening downward. Why do I know it's downward? Well, I know the a is -5, and therefore a negative makes the end behavior be going to -infinity, or in slang term, down, down. So we know it's opening downward. It's a very poorly drawn parabola, I get that. And the value of a is -5. Therefore, I know that the distance between the focus and the vertex and the directrix is 5. So I'm going to go 1, 2, 3, 4, 5. I'm going to draw my line. And I'm going to go 1, 2, 3, 4, 5 and draw my focus. This value here is 5 and this value here is 5. So my focus is going to be 3. Remember that the -3, excuse me. The x value does not change, but now I have to go down 5 from 1. So if I went down 5, you notice that it's -4. The directrix is a line, y equals, well, we started at 1, we went up 5, and so that's 6. The axis of symmetry doesn't change, it's always x equals -3. So where that line down the middle is. And you just created it. Created your parabola, you drew your directrix, you drew your focus, and you answered everything. So you can be given a full equation, and then be able to say everything about it, or you can be given aspects of the parabola, and you have to create your own equation. That's what we're going to have here. So our focus is going to be 0, 7. And that's our focus. It is not the vertex. It's key to see. That's our focus. Our directrix is y equals 3. If this is the focus and this is the directrix, we know that the vertex has to be smack dab in the middle of it. Well, if this is 7 and this is 3, in between 7 and 3 is 5. And I know that my parabola must open upward because I know the directrix cannot lie inside the parabola. The focus lies inside the parabola. And the last thing I have to figure out is, what is this distance? Well, I know that distance is 2. And after I have this, I now put everything into the equation. Remember, the equation is 4a parentheses y minus k equals x minus h squared. Or you can flip that. It doesn't matter which one goes first. So my vertex, which is right here, is 0, 5. That's my vertex. Well, if I know that's my vertex, I know that's my h, k. So I can plug in x minus 0 squared and y minus 5. The last thing I need to plug in is my a value. Well, my a is the distance between the vertex and the directrix, and vertex and focus. Sorry, this is vertex and focus here, vertex and directrix, which I know is 2. It's opening upward, so it's positive 2, and I'm done. I don't need to put the minus 0 in because anything minus 0 is itself. There it is. That's it. The key here is remembering vertex to focus, vertex to directrix. So our final 2 examples here, we're looking at creating the equation. What are we given? And then create the equation. Again, I say you have to draw it. There's no other way to do it. So 5, 4, right here, the directrix is -1. So if I know the directrix is -1, I now know which way it opens. The vertex directrix cannot be involved at the same, cannot be inside the directrix, so therefore we create it upwards. I now have to find the a value. Well, if my directrix is -1 and this y value is 4, I'm 5 away. And I don't even need to find the focus, because the equation I know is 4 times 5 not equals, I don't know what I was thinking, times y minus the y value, 4, equals x minus 5, that's the x value, squared. I'll get 20. And we're done. That is it. It is that simple and quick. If you don't draw the picture, though, it will not be that way. The last example here, we're given the vertex, we're given the focus. So put it out, -3, 2. And the focus is -3, -7. Ooh, all the way down here at -7. That's 2 and -7. The focus is inside, so I know the parabola must be facing down. That's the key. The distance from 2 to -7 is 9. And so when I go to plug in, I know the vertex. So I got x plus 3, remember it's the opposite sign. I got y minus 2. And now I have to know that it opens downward, so it's going to be negative, and 4 times -9. I'm going to get -36. And that should be our final answer. And that does it for quadratics. Congratulations on making it through, and I will see you in class.